Hello class, welcome to Instruco. My name is Nishtha and I will be your maths teacher for today. In today's class, we will learn more about LCM and HCF. Now, I am very sure all of you have heard this term, LCM and HCF. But what does it exactly mean? What is it in relation to numbers? That is what we will see in detail today. Okay, so let's start with the basic. Let's start with the full form. So the full form of HCF is highest common factor. Okay, and it can be calculated using three methods. The first method is by listing the factors. The second method is the prime factorization. And the third method is the long division method. Now, I am sure all of you know what is long division. So, yes, we will use that long division to calculate the HCF. Okay. So, once again, let's revise. What is the full form of HCF? It is highest common factor. Okay. Now, let's move to the second term. The second term is the LCM, which is also known as the least or the lowest common multiple. Okay, now this can again be calculated using three methods. The first is by listing the multiples, second is the prime factorization, and third is the division method. I want to make you notice here that for LCM we use the division method, whereas for HCF we use the long division method. So just to make sure that these two methods are different and they shouldn't be confused with each other. Okay. Now, before we start, let's understand the two major terms that we see here. One is factor and other is multiple. Now, what is the meaning of factor? Can anyone tell me what is the meaning of factor? I'm sure all of you are giving correct answers. The meaning of factor is a group of divisors which when divides a number leaves the remainder as 0. Basically, if I talk about any number, let's say 12 for instance, okay, so if I talk about 12, all the numbers that divide 12 without leaving any remainder are known as factors. So let's check the list of factors for 12. So basically the factors of 12 are 2, 3, 4 and 6. Okay, there are two factors which are not written here, which I would like to tell you. One is a factor of every number. Okay, because 1 divides every number. 12 divided by 1 is 12. 11 divided by 11 is 11. Any number divided by 1 is the number itself. But 1 is the factor of all the numbers. Okay. Another factor which is not written here is 12. So, yes, the number itself is also the factor of the number. So, let's say in this case, since I'm talking about 12, then 12 is also a factor of 12. Let's say if we were writing the factors for 10, then 10 will also be a factor of 10. So, I hope the meaning of factors is clear to everyone. I'll again repeat it. Factors are the numbers which divide the given number completely without leaving any remainder. Don't worry if you're confused. We will practice many questions to make sure we understand this concept clearly. Okay. Now let's move to multiples. What is multiples? So multiple is the product of two numbers. So let's say I have to write the multiples of 12. So what will be the multiples of 12? 12 multiplied by 2, which is 24, is a multiple of 12. Then 12 multiplied by 3, which is 36, is also a multiple of 12. Then 12 multiplied by 4, which is 48, is also a multiple of 12. So as you can see, there is no end to the multiples of 12. You keep multiplying 12 with whole numbers and you will keep getting multiples. So the key point that is to be noticed here is that the number of factors of any given number are limited. Okay, like in case of 12, you can see 12 has a total of 6 factors: 1, 2, 3, 4, 6, and 12. But the number of multiples of any given number are infinite. You keep multiplying the number with different whole numbers and you will keep getting the multiples. Okay, so there is no end to the multiples. Now the thing to notice here is that is why we calculate the highest common factor, because number of factors are limited. So you can, if I give you two numbers and if the factors of both the number are given to you, you can quickly just see and tell me which factor, which common factor is the highest, right? But in case of multiple, as you can see, we calculate the least or the lowest multiple because we cannot calculate the highest multiple, because as you know, the numbers are infinite, so the multiples of any numbers are also infinite. Okay. Okay, now let's move to the warm up activity of this chapter. Before we start with the warm up activity, I would like to explain you a little bit about prime numbers. Okay, so what are prime numbers exactly? Now, prime numbers are the numbers which are not divisible by any other number. Okay, so basically to say my prime numbers are 2. See, 2 is not divisible by any number. 2 does not come in any numbers table. 3. 3 is a prime number. 5 is a prime number. 6. 6 is not a prime number. Why? Because 2 multiplied by 3 is 6. So 6 is divisible by 2 and 3, right? So that is why 6 is not a prime number. Prime numbers are the numbers which are not divisible by any other number. Okay, and remaining all the other numbers are called composite numbers. Okay, so 6 will not be a prime number, but it is a composite number. Okay, all the numbers that are not prime are called composite numbers. Okay, now another thing to notice here about the prime numbers is that they only have two factors, one and the number themselves, because as I said, they are not divisible by any other number. So that is why they only have two factors. So if we talk about 2, the two factors that 2 has are 1 and 2. I can easily divide 2 by 1. 2 divided by 1 will give me the answer 2. And I can easily divide 2 divided by 2 also, because that will give me the answer 1. Other than these two factors, 2 has no other factor, right? So this is a very major sign of prime numbers. Okay, let's do the same with 3. So as you can see, 3 is also a prime number. So 3 is also divisible by only 1 and itself. Okay, so prime numbers are always only divisible by 1 and itself. Okay, whereas if you check for 6, and 6 we know is a composite number. So 6 is divisible by 1, 6 is divisible by 2, 6 is also divisible by 3, and 6 is also divisible by 6. So if any number has more than two factors, which is 1 and itself, then it is not a prime number. Then it is a composite number. Prime numbers necessarily will have only two factors, 1 and itself. Okay, I hope this is clear to everyone. Now let's practice a few questions on prime numbers. So now here I have to write down the prime numbers between 40 and 60. Okay, before I start doing that, I would like to explain one thing to you, that there is only one even prime number. Okay, now before we understand it this way, I hope all of you are clear with the meaning of even and odd. All the numbers that are divisible by 2 are even numbers. Basically, all the number in which at the ones place we have 0, 2, 4, 6 or 8 are called even numbers, and all the numbers in which at the ones place we have 1, 3, 5, 7 and 9 are called odd numbers. Okay, now as you can see, there As I said, only one even number is a prime number, and that is 2. And 2 is our smallest prime number. Okay. Other than that, none of the even number is going to be a prime number. Can you take a guess as to why this is? It's very logical actually, because the even numbers at least have one more factor other than 1 and itself, 2. That is the key point about a even number, that it is always divisible by 2. So no matter which even number I'm talking about, it will at least have one extra factor other than 1 and itself, and that will be 2. So that is why even numbers can never be prime numbers. There is only one even prime number, which is also the smallest prime number, which is 2. Okay, now let's come to the question. This question says write all the prime numbers between 40 and 60. So 40 is even, 60 is even. They both cannot be prime. Okay, now let's start from 41. So 41 is not part of any table. 41 is not divisible by any other number except 1 and 41. That is why 41 is a prime number. Okay. 42, no, because it is an even number. Okay. Next, 43. Yes, 43 is also a prime number. 44 is not a prime number because it is an even number. 45 is not a prime number because it is divisible by 5. 46 is not a prime number because again it is an even number. 47, however, is our next prime number. Okay. Again, 48 is not a prime number. 49 is also not a prime number. Take a guess as to why. Yes, because it is 7 square. It comes in 7's table. 7 multiplied by 7 is 49. So 49 has another factor other than 1 and 49, which is 7. So that is why 49 is also not a prime number. Okay. Now 50, again, even number, not a prime number. 51. Well, 51 comes in 17's table. 17 multiplied by 3 is 51. That is why 51 also has more than two factors. That is why 51 is also not a prime number. Okay. 52 is again even, so not a prime number. 53, however, is a prime number. 54, no. 55, no. 56, no. 57 also no, because 19 multiplied by 3 is 57. Okay. 58 even, so no. 59 is a prime number, and as we already discussed, 60 is not a prime number. Now see, take a minute to observe here that all the prime numbers that we have got are odd numbers. So it is compulsory for prime numbers to be a odd number, but doesn't mean that all my odd numbers will be my prime number. Okay. And there's only one exception to this rule, which is number 2, because it is even and prime. Okay. So I hope the remaining questions you would be able to do. Composite numbers are the numbers which are not prime, and here also they are just writing the prime numbers. So now let's move to the next part of the chapter. Okay, in this next part we will be studying about the factors. Okay, what are the factors? Okay, so as we wrote there, here also we will start write the factors of 20, 36, 40, 52 and 100. We won't be able to do all the questions in this class, but let's pick a few difficult one. Okay, so let's start with 36. 36 has many factors. Okay, so now whenever it is asked from you to write the factors of any number, you always start by writing the smallest factor, which is 1, and then by writing the largest factor, which is 36. Now that I have written these two factors, I can say that all my other factors are going to be in this range. Basically, all my other factors will be greater than 1 and less than 36. Okay. And also another important trick to write the factors so that you never miss any factor is always write the factors in pairs. Okay, so like for instance, I know that 36 is divisible by 2. Okay, but what I also know is 2 multiplied by 18 is 36. So not only 2 is a factor of 36, but 18 is also a factor of 36. And guess what? By writing 2 and 18, we have narrowed our range even further. Now all my remaining factors will be between 2 and 18. So let's see. Next factor for 36 is 3, because 36 is also divisible by 3. So again, let's write the factor but in sets. So 3 multiplied by 12 is equal to 36. See, again I got two factors, 3 and 12. Next, we know that 36 is also divisible by 4. So we will write 4 and we will write 9, because 4 multiplied by 9 is equal to 36. Now, all my remaining factors will be between 4 and 9. So now I only need to check these 5 numbers. So start checking them quickly. 5 is not a factor of 36. 6, however, is a factor of 36. So the only factor that is left to be written here is 6. Why 6 single? Because 6 multiplied by 6 is 36 and there is no point writing 6 twice. So we will only write 6 once. So now we have covered the entire range, which has given me almost 9 factors for 36. Okay. I hope this is clear to everyone how to write factors of any given number. Okay, don't worry, we will practice one more question, okay, of the same type, okay. So let's take 52 this time, okay. So again, we start by writing the smallest factor, which is 1, and the highest factor, which is 52. Now, I know for a fact that all my remaining factors are gonna be between this range. Also, 52 is an even number, so 2 is definitely a factor of 52. Now 2 multiplied by what is 52? Right, 2 multiplied by 26 is 52. So we get two factors of 52, 2 and 26. Okay. Next, as we can see from here, 52 is not divisible by 3. Okay, let's check for 4. 52 is divisible by 4. So another factor of 52 is 4. Now what is the number which when multiplied by 4 gives us 52? Right, that number is 13. So here are my two other factors of 52, which are 4 and 13. Now make sure if there is any remaining factor left, it has to be between this range, between 5 and 12. So let's check all the numbers from 5 to 12. 5 is not a factor of 52 because it is not divisible. Okay. 6. See, how can we check whether 6 is a factor of 52 or not? Sorry, whether 52 is a factor of 6 or not? See, very simple. All of you know the table of 6. Okay. Now look for a number in 6's table which is close to 52. So I can say that 6 times 8 is 48 and 6 times 9 is 54. So see, clearly it established that 52 is not coming in 6's table. So my two factors of 6 become, so basically I can say 52 is not a factor of 6. Now similarly, let's check for 7. 7 sevens are 49 and 7 eights are 56. So 52 is not a factor of 7 also. Let's check for 8. 8 6 are 48 and 8 sevens are 56. So 52 is not a factor of 8 also. Let's check for 9. 9 fives are 45. 9 6 are 54. So 52 is not coming in 9's table also, which means 52 is not a factor, which means 9 is also not a factor of 52. Now let's come to 10. Clearly, 52 is not divisible by 10 because it does not have 0 at its ones place, right? So 10 will also not be a factor of 52. Now 11, 11 fours are 44, 11 fives are 55. So we have no 52 in 11's table. So 11 is also a no. Now come to 12. 12 fours are 48, 12 fives are 60. Again, we don't have any 52. Means these are all the factors of 52 that we have written here. Okay, I hope with this it is clear to everyone how to write the factors. Okay. Now, let's see how to write the multiples. Multiples is actually very easy. It is saying only to write the first 5 multiples. Since 6 is already here, I will start with 12. So, multiples of 6 are the numbers that come in 6's table, right? So, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30, and 6 6 are 36. These are the first 5 multiples of 6. Simple enough? Okay, let's take one more number and write the multiples of that. So we will try writing the multiples of 15 now, okay? 15 twos are 30, 15 threes are 45, 15 fours are 60, 15 fives are 75, and 15 sixes are 90. So these are my first 5 multiples of 15. So I hope you understand how to write the multiples. It is actually the numbers that would come in 15's table, or whichever numbers multiple you have to write. Basically just write down the table of that number. Okay? Okay. Now we are going to learn prime factorization. Okay. Why are we learning prime factorization? Because it is very important to calculate the LCM and HCF. And this prime factorization method is used to calculate the LCM. See, it's written here. The prime factorization method is used to calculate the LCM, and this prime factorization method is also used to calculate the HCF. That is why we are learning how to do prime factorization. Okay. Now, prime factorization is again divided into two methods. Okay. The first method is the factor tree method, and my second method is the division method. So in factor tree method, we make a chart like this. Okay. And in division method, we make a chart like this. Okay. Now, what is prime factorization? So, as the name suggests, factorization is factors, right? And prime factors are the ones which cannot be divided any further. Okay. So basically, when we break any given number in its prime factors, then that is prime factorization. Like, let's say if I have to break 12, okay, I know 6 into 2 is also 12. 6 into 2 is 12. So you can say, ma'am, 6 and 2 are the factors of 12. But see, 6 is not a prime factor. That is why this is not the prime factorization of 12. However, if I break 12 as 2 into 2 into 3, see, this would again give me the answer as 12 only. 2 multiplied by 2 is 4. 4 multiplied by 3 is 12. But see here, all the three inputs are prime. So that is why this is the correct method to do the prime factorization. Okay. Basically, when we break any given number in all its prime factors, that is called prime factorization. Okay. So let's start with our first method. Our first method is the factor tree method. Okay. So these questions have to be solved using the factor tree method, and we need to write the prime factors of all the given number. Okay, so let's take the B question and solve it. So as I told you, in factor tree method, we make a chart like this. So circle, break it into two halves. Okay, now here you can write any two factors of 64. Okay, any two factors of 64. Okay, like for example, I can write 4 and 16, because 16 multiplied by 4 is 64. So I can write 4 here and 16 here. Okay. Or I can also write 8 and 8, because 8 multiplied by 8 is 64. Or I can also write 2 and 32, because 2 multiplied by 32 is 64. So basically you have to write any two factors of 64 which when multiplied together will give me the above number. Okay. Now, for basically for reducing the steps, I will break 64 into its maximum or the highest factors, which is 8 multiplied by 8. So the two factors of 64 are 8 and 8. As you see, when we multiply 8 with 8, it will give me 64 only. Now, there are two circles. Now, again, from the two circles, we will make two branches. Okay. This is why this method is called factor tree method, because it looks like a tree. Okay. So now again, we have given two branches. Now you must be thinking, ma'am, till when will we give them two branches? Till the time we don't obtain all prime numbers. Okay. Now, like for example, 8 can be written as 4 multiplied by 2. Correct. So the two factors of 8 are 4 and 2. Similarly, here also 8, I'll again write 8 as 4 and 2, because 4 multiplied by 2 gives me 8. Now we will not break 2 any further. Why? Because 2 is a prime number. So we already got a prime number, right? So I have one prime number here, one here. So now we will only break the non-prime numbers or the composite numbers, okay? So in this case, we will break the remaining 4s because they are not prime, right? So 4 is broken down into again 2 and 2. And this 4 will also be broken down into 2 and 2. Okay. So now let's quickly count the number of 2's that we have obtained, because these are the prime factors of 64. Okay. So see, 1, 2, 3, 4, 5, 6. Now, this cannot be solved any further. Why? Because 2 will not be, you cannot break 2 in two parts, because 2 is a prime number, right? So, what are my prime factors of 64? They are 2 multiplied by 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 2. Basically, 2 is multiplied 6 times. Okay. So this can also be written as 2 to the power 6. Got it? Now, if I want to check whether I have written the correct prime factors of 64 or not, what will I do? I'll just multiply them together. And if I get the number 64 again, means I have written the correct factors. So should we cross check our answer once? So see, 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 multiplied by 2 is 16. 16 multiplied by 2 is 32. And 32 multiplied by 2 is 64. So yes, my prime factors are absolutely correct, because I am getting the number 64 when I am multiplying them. Okay, so this is the first method, which is called the factor tree method. Now we will see how to solve questions by other method. So prime factors can also be found out using the division method. Okay, so let's see what we do for division method. So as I told you, in division method we make a chart like this. Okay, write the number 96. So because we are doing question number B, so the number for which the prime factors are required is written inside. Now we will look for the smallest prime number that will divide this 96. Okay, so because 96 is even, so the smallest prime number that will divide 96 is 2. So the divisor will be written on the outside, okay? And the number that I'm dividing is written on the inside. Now divide 96 with 2, and whatever the answer is will be written here on the next step. So 2 4s are 8 and 16. So 2 8s are 16. So when I divide 96 by 2, I get 48. Now again, repeat the same with 48. Smallest prime number which would divide 48 is again 2. So I'll write 2 here. So I'll write 2 here, and my answer will be 24. Now we will continue this process till the time we get 1. Okay. So let's see. Again, let's divide it by 2. I get 12. Again, let's divide it by 2. I get 6. Let's again divide 6 by 2. I get 3. Now 3 is not divisible by 2. Right? So which is the next number, next smallest prime number that would divide 3? 3 itself. Correct. So I'll divide 3 with 3, and see here I got 1. So once we get 1 here, then our job here is done. Okay. So now I can write the prime factors of 96. So my prime factors of 96 are 2 multiplied by 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 3. Right? This can also be written as 2 to the power 5. See, because there are 5 2's now. 1, 2, 3, 4, 5 multiplied by 3, because there is only 1 3. Now again, let's cross check our answer, that whether the prime factors that we have got are correct or not. Okay. So like I said, for that you need to multiply and see. So let's multiply. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 multiplied by 2 is 16. 16 multiplied by 2 is 32. Sorry, my bad. I went wrong somewhere. So let's do it again. 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. 8 2s are 16. 16 2s are 32. Correct. And 32 multiplied by 3 will give me 96. So see, since I'm getting the number 96, means that these are the correct prime factors of 96. Okay. So, in today's class, we will stop it till here. First, practice well how to calculate the prime factors or how to find out the prime factors. After you are fluent in that, I assure you, you will not have any problem in calculating the LCM or the HCF, as this method is very important for calculating both LCM and HCF. Okay. So have a good time and practice lots of questions. Okay. Bye guys. Have a good day. Thank you.